Hi, everyone. Welcome to today's webinar. My name is Brianna DeLuca, and I'm a Senior Field Marketing Manager here at HashiCorp. And today we have Justin Weissig on our technical marketing team, and he's going to talk through an overview of HashiCorp as well as Vault and Secrets Management. And then we are excited that we have Jeff Burns from athenahealth here, and he's going to talk through how they're utilizing HashiCorp's Vault to automate secrets management to secure secrets that protect hundreds of millions of patients and business records and more. And then after the presentation, we are going to go into Q&A with Justin and Jeff. So if you have questions throughout the presentations, please feel free to put those in the Q&A portal, and we'll ask them at the end. I just want to note that this webinar is being recorded. And I will send it all out to everyone that registered, most likely early next week, and it will also be made available on our resource library on our website. So with that, I'll turn it over to you, Justin.
Hey, awesome. Thanks very much. And thanks for joining the webinar today. So as Brianna mentioned, we're going to go through a sort of a brief overview of, what HashiCorp is, our various products, just quickly, just to sort of, I guess, set the stage for what we're going to chat about today. I'll sort of dive into Vault sort of 101 for a couple minutes, and then we'll chat about sort of the overall workflow that it enables. But before I get too far, I would actually like to introduce, so I'm a co-presenter today. I'd actually like to introduce Jeff, who's a SRE lead over at athenahealth, who is one of our customers, who is kind enough to join the webinar today. So I'll kick it over to you for a couple seconds, Jeff.
Yeah. So as Justin said, I'm Jeff Burns, the lead SRE at athenahealth. I'm on what's called the core production team, and our responsibility is the health and well-being of a product we call athenanet. This is used by hundreds of thousands of medical providers, from your solo doctor's office up to some hospitals even. Lots and lots of folks depend on us to help them manage their healthcare offices, and so obviously high impact. And Vault's a big part of how we make sure that that is safe and secure and very resilient. So yeah, so happy to be here with everyone. Thanks, Justin.
Hey, awesome. Thanks very much. We're super happy to have you on the call too. So I'm going to jump over. We'll just jump through a couple slides, maybe for about 10 minutes, just to sort of set the stage, and then we'll kick it over to Jeff to sort of go through, athenahealth's use case. So I imagine most of the folks on the call today are probably familiar with HashiCorp since you joined the call about Vault, but I just sort of wanted to chat about at a high level about what HashiCorp does and sort of our products that we have. So a lot of folks are probably familiar with, say, products like Terraform, Vagrant, Packer, Nomad, obviously Vault and Console. And just a few weeks ago at HashiConf, we launched 2 additional products, Boundary and Waypoint. A lot of the sort of focus around these products, they're both open source and enterprise, are to enable developer workflows, specifically around sort of automating manual tasks. This spans sort of the entire technical stack from at the networking level with Console, developer workstations with Vagrant, creating infrastructure with Terraform. So it doesn't really matter what sort of layer of the stack you're working in. Chances are you're probably touching some of our tools. So this is sort of where I wanted to get into Vault for a second. So what is Vault, and how can you sort of take advantage of it? Sort of what's the problem it solves? So you can think of Vault as a central service you'll put on your network within your company, and it's used to sort of store and retrieve secret data. What is secret data? Secret data can be kind of thing that you want to protect. Typically it's passwords, but we also have encryption functionality. So a good example is, say you have a three-tier web application. Maybe you have a web some application on there that you're serving up, and then you'll have some sort of a database backend. Typically in this very simple architecture, you're going to have a whole bunch of secrets that you want to protect. You're going to have TLS certificates to encrypt traffic, HTTPS, so that you have a secure connection. If it's, you're probably going to have some sort of login system on that web app, that's includes usernames and passwords. You'll probably want to keep that data protected, maybe even encrypted. Typically, maybe you're processing transactions on there. You're going to have credit card data, all sorts of PII data. You might be sending emails. You're going to have, maybe payment processing. You're going to have API keys and a whole slew of sort of this secret data that you need to manage. And additionally, when you're connecting into, say, a database to actually store all this data, you're going to have a database connection string, which is also going to have secrets, and then whatever PII data, you're storing in the database. So even for a very simple, 3-tier web application, you have a whole slew of secrets. These could be sitting on the file system. They could be sitting in source code, config files. They might be sitting in, an Excel spreadsheet somewhere or something like that. And it's sort of tough to manage all this because you don't have a life cycle of actually knowing, who has access to this data, when was it rotated, if there's some sort of, breach or compromise or something like that, what passwords do you need to rotate? So it becomes sort of this problem that you need to handle. And, that's just for, a simple use case, like a 3-tier web app. Imagine, you're at a startup or a megacorp or something like that. Chances are you maybe have thousands of these, little web apps or, larger systems. And all of a sudden, the complexity of managing the secrets sort of explodes, right? So that's sort of the problem that I've defined. So how does Vault help you sort of fix that problem? So as I mentioned, Vault's sort of a centralized server that you'll put on your network. And you can talk to it, through CLI, API, or a web interface to sort of, store and retrieve secret data. Why is Vault, why use Vault? So Vault, not only gives you the capability to sort of, store the secret data, it also enables a centralized workflow. So when you're onboarding applications into Vault, you can say, okay, if I want to store this type of secret data, here's sort of the workflow for putting that into Vault. Vault is obviously highly secure. It's audited and logged, and it has a bunch of cool features for interacting secrets. You could think of it almost sort of like a Swiss Army knife of secret or something like that. And what this allows you to do is, as you're onboarding applications to it, instead of each team sort of rolling their own way of doing things, say, hey, I'm going to hard code things just because it's easy. Or, when we were a small startup, it was just easier to hard code things. And then, as we sort of grew, it becomes a much larger problem because you have a lot more people interacting with this stuff. So when you use Vault, it enables this centralized workflow, which gives you sort of assurance that, hey, if there was some sort of a breach, or I need to rotate secrets, or I need to figure out, what applications were using the secrets, you can just go to Vault and you can check out the audit logs and all that sort of stuff. It also increases developer productivity because you have a standardized process right now. So, if you have a bunch of developers and they need to go and access secret data, they don't need to go and roll their own solutions, right? I think I've sort of set up why Vault is useful, but I'll just jump to the next slide here. And I sort of want to chat about the sort of ecosystem that surrounds Vault. So, as I sort of mentioned, Vault sits in the center here. It has a bunch of ways you can interact with it, through the API, through the command line, or through a web interface. But we have a bunch of, authentication methods for how you can actually connect to Vault and, attach your identity to it. And then within Vault, you will have a bunch of policies that you can say, this identity can, retrieve these specific secrets, or use this particular functionality. So you might set up, a single sign-on or something like that, or you might have an auth token that allows an automated process to connect into Vault and say, hey, I need the payment processing API key. Can you provision that to me? So that sort of allows the identity-based access within Vault. But on the sort of secret storing side, we also have a bunch of capabilities around. We call them secret engines, but you can think of them almost like plugins, where you can turn on and off various functionality. So I'll just touch on a few of these because there's some cool ones in here. So say, for example, you're dealing with credit card data, or maybe passport data, maybe you're a hotel or something like that, and you need to store secret data in there. You can use a transit secret engine, which is, allows you to encrypt and decrypt data. So you can pass it a string, it'll pass back ciphertext, and away you go. Same thing with the transform secret engine. This allows, you want it to store that database. There's obviously a problem presented with that, and that, extremely PII data. Some dumps your database, credit card numbers, obviously that's a problem. So using the transform secret engine, you can tokenize that data and store it in a database, and it will be encrypted. You don't have to change the schema to, within the database to support that. And want to do something, typically you'll get a highly privileged AWS API key that has a bunch of functionality associated with it.
Hey, Justin.
What you can do is,
Sorry, the audio.
Yep.
Can you hear me? The audio went out like the
yes,
last
I can hear.
20 seconds. If you want to, it kind of went in and out the last 30 seconds you were talking.
Oh, sorry.
No worries.
Oh, okay, great. So maybe I'll start over on the right hand side here. The secret data, is that a good spot? Perfect.
That'd be great. Mm-hmm.
Okay, sorry about that. So over on the right hand side here, we have a bunch of we call them secret engines. They're also, you can think of them as plugins that allow you to turn on and off various functionality. This is sort of where the Swiss Army knife of Vault comes into play, in that, say you had a requirement to encrypt or decrypt data, you could use a transform secret engine. Or maybe you want to use vaultless tokenization. Maybe you had credit card numbers you wanted to protect. You could use the transform secret engine. And there's a bunch of sort of more advanced functionality in here, specifically when you get into dynamic credentials using a cloud provider. So say you want to connect to AWS, and maybe you have an automated process that's going to spin up some, infrastructure or something like that, and you need a AWS credential to do that. The cool thing about Vault and Dynamic Secrets is Vault can actually provision you a short-lived, token that will expire, API keys. So, say for example, you'll have an automated application that'll ask Vault, hey, can you grab me an AWS credential that's valid for a few minutes? Maybe you're provisioning infrastructure, maybe you're storing something in S3, or maybe you had a backup job that needs to dump a database and store it somewhere. You can ask Vault, hey, grab me an AWS credential. Vault will go and create an AWS credential for you that has a time to live that you can specify. It could be hours or days or even minutes. And then the cool thing about these dynamic credentials is if, say, one of these credentials leaks out, or there's an exposure or something like that, there's a brief window where you can actually take advantage of that, versus having these long-lived, highly privileged keys sitting around. So in each one of these secret engines or sort of plugins, obviously they're full featured, and typically you'll have a whole slew of use cases associated with these. So when you look at the sort of problem of having secrets sprawled throughout your infrastructure with no capability to know the provenance, or say a developer leaves the company and they take off with a bunch of your secrets, you don't really have that ability or audit trail to know what your impact is. Or, if you have a breach, you don't, the sort of blast radius of what happened. Whereas if you have Vault, typically you'll have someone coming in that's using a token that verifies their identity. Then you'll have a policy associated with that identity that can, limit their scope to a various set of secrets that they have access to. And then you can take advantage of all the sort of advanced functionality in the secrets engines that we have. So I think that probably sets the stage for, what Vault is and why folks are using it. Jeff, if you're ready, I'll probably pass it over to you. I'll also mention that, obviously, if you have any questions about any of this, please use the Q&A section. It can just be Vault general questions, or obviously specific stuff to, what's Jeff's use case here. So we're happy to answer any questions. All right, I'll kick it over to you, Jeff. Thanks.
Great. Thanks, Justin. So yeah, again, Jeff Burns, lead SRE, there are a few of us, at athenahealth. And we spent the last year in a pretty deep engagement with HashiCorp, building out our usage of Vault Enterprise. And as the slide says, we're going to talk a little bit about how athenahealth, who's a pretty big healthcare services company, kind of took advantage of what Vault offers. So setting the stage of our use case, we had built out an open source implementation of Vault last year, and we were doing about 300 million requests a day to that cluster. And we serve 40% of the patients in the United States, and growing all the time, over 160,000 providers in our network of customers and clients. And in the process of adopting Vault, we centralized a number of homegrown systems into a single secrets system. We have a lot of different kinds of use cases, from the very simple to some of the more dynamic ones that Justin was talking about. We are still in the process of developing some of those dynamic uses. So, here's our challenge. We have a lot of patient and platform records. All of those providers, they have patient records stored within us. So, HIPAA law comes to bear, patient safety, privacy, all of these things are of the utmost importance. None of us want our healthcare information to be, shared or not secure. So obviously we take that really seriously. That's a challenge. That's hard. So, how do we go from a posture that was really onerous, really just manual and prone to error, to one that's more automated, when we can leverage infrastructure as code, we can leverage continuous integration and continuous deployment practices, and really increase developer and administrative safety, which will then, of course, increase everyone else's safety and security. At the same time, that actually also, reduces our costs. We need not fewer things, but we need, we could better take advantage of our virtualization functionality. We have a big VMware footprint in our data centers, and we have cloud footprints as well in AWS, Azure, and I think a little bit in Google Cloud. I don't touch it very much. And just reduce the surface area for mistakes and issues and incidents. So this is we spent a lot of time coming up with this explanation for why we chose Vault. We wanted to streamline, standardize, and systematize athenahealth's secrets management operations. Streamline, that's an obvious good thing. We want it to be straightforward. Standardize, because we had multiple solutions. That meant there were multiple maintenances happening. There were multiple ways to get a secret into production. This is confusing at best and dangerous at worst. But systematize is probably the most important one long term, and will really contribute to our growth, and will really multiply our ability to take on new needs for athenahealth and maintain the existing functionality. This really gets to the ability to program Vault to do what you need via policy, via configuration, and take advantage of the other HashiCorp products to support it. We make heavy use of console as well to make sure we're talking to the right Vault and ensure that, we're talking to a healthy vault, and things of that nature. So all of this gets us away from manually doing things and into a place where, multiple hands are looking at the same stuff and operating on it all together. So this is where we are today. We took a bunch of bare metal secret servers doing various secrets work. We stood up virtual machines instead to run the Vault clusters. We've not only transitioned to Vault, but that also meant that we made those services more highly available, introducing a ton of resiliency compared to the old systems, and even compared to our original open source implementation that we did ourselves before engaging directly with Hashi. The secrets policy application stuff, there are now multiple teams owning their policy implementation in service to other stakeholders. So my team is the broad service itself. We maintain the root level and our own namespace, and then we maintain the administrative controls for a higher level namespace that the application teams use. The folks who actually build AthenaNet itself and write a bunch of application code. And that is actually entirely owned by a whole other team that operates out of India. And they own that. They're the admins, so I give them access, and then they manage that themselves through their systems. And, and that's, of course, a whole different set of needs that I'm not as concerned with based on where I am in the stack. So that's a huge, huge win for us. I don't have to do everything for them. I can enable them to then create their own little land of secrets policy and do what's necessary for the application folks who I'm at some distance from. It's completely done away with the manual ticketing that we needed to actually get secrets in play. Previously, you'd open a ticket with us, and we would insert the secret into the system, and then it would probably stay there forever, even if maybe it wasn't used anymore. And this, of course, was very high touch and very slow, and also meant my team was a bottleneck, which was not great, especially if the secret was really sensitive. In addition to that, we had a memcache layer in between the application and Vault, purely to handle the load that we were putting on it. The open source system that we had built, we didn't realize how much how much we needed in terms of scale right from the jump. So that was shimmed in there to get us to the next place, which is why we initially engaged with Hashi and said, hey, we built this, it's great, but we didn't realize how much it needs to scale. We need your help. What do we do? And they're like, well, let's take you on a journey. And lo, we have now we're running the enterprise version. And in the end, this has reduced our costs. It's way cheaper to run a bunch of VMs than it is a bunch of bare metal servers. Just from that stance. And the harder costs to the harder costs to see are the costs of like me having to deal with these secrets requests and the operational complexity that was introduced by having a single team bottleneck things. Really good stuff. So this is a quote from my my cohort, Ganapathy, who is the engineering lead and was basically my counterpart on the secrets team, which, as I mentioned earlier, is sort of the application service team and handles the policy for AthenaNet itself. And Ganapathy shared that Vault has proven to be a great equalizer for us, helping find the balance between ensuring the security and protection of our sensitive data and minimizing the amount of time and effort it takes. And I think that really sums it up really well. So that's what I've got for athenahealth and kind of our journey here. I'm happy to speak in more detail about any of that, but I'll hand it back to Justin.
Hey, awesome. Thanks very much. Brianna, I'll let you be the MC.
Okay, cool. Thank you both, Justin and Jeff. That was great. So as we mentioned before, if you guys do have any questions, put them in the Q&A portal as we'll be answering them live here. So the first question that came through, I know, Justin, you answered it, but might be helpful for everyone else. Is there a way to do a private service with Vault for doing TLS internal communications on private cloud networks?
Yeah, totally. So I'm not actually familiar with what the interface looks like as an attendee, but I assume you can probably see the answers to the questions. So in the question there's a link we have. When I was talking about, let me just switch to the slide actually. When I was chatting about these secret engines that the functionality that Vault has, there's actually one called PKI. PKI certificates. This is a secret engine. You could think of it like a plugin too that you can turn on that'll give you that exactly that functionality. It'll act as an internal CA. Also in that the question that came in the typed out answer, I included a page to something on the HashiCorp website called Using PKI with Vault. And on that page, you'll have a whole slew of links, from documentations, but there's also a really cool YouTube video on there. It's about, I think, about half an hour long, and it goes through, how to do that. There's actually a live demo with one of our SEs, where they stand up the entire infrastructure, generate a bunch of certificates. So, if you're looking to get pointed in the right direction with sort of playing around with that or rolling it out, that's definitely the sort of link to check out. Thanks.
Perfect. Thanks, Justin. And then this next question was for Jeff. So what's the percentage? It was more on like how many developers are using Vault on a daily basis. So if you could give a percentage of developers using Vault on a daily basis, what would you say at Athena Health?
So I don't have any. I was starting to type an answer, but then I figured we'd just do it out loud. So I don't have a number to give. But the short version is all of them, generally speaking. In terms of writing policy or getting or setting secrets themselves, it's certainly a smaller number on a daily basis, but we're still talking about hundreds of people interfacing with this system on a regular cadence. There are, it's a lot of data to throw around, and there are a lot of secrets associated with that data. So it's a big system for sure.
Perfect, thank you. And so the next question that came in is for Justin. So kind of what point do you recommend the enterprise version instead of the OSS version? And the other question kind of touched on that too, for smaller companies with less than 10 employees.
Sure. So maybe I'll just address OSS, open source versus enterprise. So obviously there's a massive open source community around Vault. Like if you go to the GitHub page, you'll see hundreds of contributors, lots of things being worked on. We're really OSS first, like open source first, and genuinely, support that. I think it shows through the GitHub page. So I guess the larger question here is when would you actually transition to using Vault? You're a lone developer or even a group of 3 or 4 developers, working on a project, and you have a 3-tiered web app. I think it's a bit of a stretch to say, oh, I'm going to spend, Vault infrastructure and manage this other, just so I can, single like that. Personally, I think that, a little bit overkill. Where you have to run into it is when you really realize, hey, I have this sort of secret sprawl, like sort of the problems that I was mentioning before. If you're really worried about, protecting PII data, if you need to encrypt a bunch of stuff, to do vaultless tokenization, if you need to protect, payment, card transactions, if you have a highly dynamic AWS environment and you're issuing tons of API keys all the time, or those are really the use cases where you're going to find a huge amount of benefit in, offloading that responsibility to Vault. I don't want to say it's going to become obvious, but it's going to be obvious that, hey, you have some sort of a problem of hey, we have a bunch of secrets flying around and I'm concerned about, security of this. I think at that point, you'll start researching, hey, secrets management solutions. And that's how a lot of folks, come to use Vault, especially open source. There's a massive community of folks just run source. When do people hit a position of, hey, I'm using open source, I want to use enterprise? Well, that's there's lots of startups that obviously are using it, as well as enterprise customers. It's really when you run into, hey, I'm running in multiple data centers, I need to do, or I have high transactions rates. Maybe I'm doing, multiple thousands of transactions a second or something like that. How do you actually handle so we get to, high idle clusters, disaster recovery, performance replicas, obviously support. Those are all enterprise. So that's sort of the progression of, you're realizing, hey, I have a problem, to how do I use open source. Tons of people never leave the open source space, and that's like awesome. And then, obviously we're supporting the people that have higher needs. So hopefully that's, a broad way of answering the question, but hopefully that answers it.
Yeah, that's great. Thanks, Justin. So the next question that came in was for you, Jeff. So he's sorry if he missed it, but he wasn't sure. How long did it take for you guys to set up Vault at athenahealth? Was it months? Was it weeks? And how was that adoption process?
Yeah, so months probably to build the enterprise scale one we did. The adoption process, as you might imagine, took a lot longer. It's a heck of a migration we did with the initial open source build out. Athenahealth is a sprawling application with multiple pieces that kind of come together into a larger system. So that took a few months. I think 6 to 9 months is how long it took the Sears team to migrate all but 2 internal customers to using it. Those last 2 are a holdout simply because they have very specific compliance-driven needs that the old key service was providing that Vault has yet to do, and not because it can't, but because we haven't built it yet. But they are in the middle of transitioning as well. One of those was a FIPS 140-2 compliant use case with regards to personal health information. So that we needed to be really that basically prescription data for people was being passed. So, as you might imagine, we got to be extra careful with that, even more so than most things. So we're in the middle of taking advantage of some of the dynamic functionality in Vault, as well as the fact that it is, certified for that level of like security compliance. But in the past, I've built out Vault systems at much smaller firms with far fewer or no compliance requirements. We're talking a 5-person company and a 70-person company, to give you some idea of the size difference compared to Athena's 5,000. And I've managed to build small Vault clusters in about a week or 2, and set up just some very straightforward policy for that few people. You can kind of just give everybody who works there the keys to use it, and just enjoy the extra security it gives you in general. So it's not too bad, and the guides are great.
Perfect, thanks. So we'll stay on for another minute to see if one more question comes in, but we really appreciate Jeff joining us to talk through athenahealth's use case for Vault, and thank you to Justin as well. So we'll stay on for one more minute, see if there's any questions that came in, but thanks all for joining and sending in your questions. And just a note, as I mentioned before, this was recorded. So if you guys do want the recording, I will send it out to everyone that registered with an email. And then it will be also on our site available for everyone. Okay. And if you guys do have any questions that come up, feel free to email me. I know you guys have my email because I've been sending them out for the webinar, and I will forward them on. So thanks again. Thanks, everyone. Oh, it looks like there was one question that came in. Would you recommend it, since you did use it with smaller companies you were talking through, would you recommend it for even a small company with only a few developers, since you've had experience in both?
Yeah, so to answer your question directly, Geronimo, I wouldn't spend a ton of time and energy doing anything, really crafted. If you're going from a place where like we just hand out passwords to everyone and whatever that looks like, I would just kind of lift and shift it to Vault and keep the policy very simple so you don't create a lot of headaches for yourself. But the dynamic secrets functionality, I cannot overstate how awesome it is to plug your database systems, your API functionality, like whatever it is that could take advantage of it. I mean, the really simple one that has been solved basically since day one with Vault is like you plug your database into it, You give Vault admin power over the database, and now Vault controls all the database passwords and rolls them for you. And you use some mechanism to distribute those, perhaps Vault itself with some other wiring, to your applications that need it. So like, your app needs the password. It asks Vault. Vault is controlling the password and setting it in your database, hands the app a password. It's only good for an hour. So like a lot of headaches just go away, and you kind of start from a really strong security stance. It's very hard to add security later. So, if you have the ability to spend some time and energy just adopting it in the simple form early on, you can just kind of grow your usage of it as your needs come up, instead of suddenly having to be, oh, I need better secrets. So yeah, I think it's useful at almost any level if you have a secret, if you have stuff you can't just put in code.
Great. Thanks, Jeff. All right, I think that was the last one that came in. So hope you all enjoy the rest of your day. Thanks again for joining, and enjoy the rest of your day. Thank you.
Yeah, awesome. Thank you. Thanks, Jeff.
Cheers. You're welcome. Bye, y'all.
See ya.